Hi, everyone. Thank you so much for joining the live Q&A session today. So with us, we have Fernanda Viégas. Thank you so much for joining, and thank you for the incredible talk. It was so good. For those of you who have questions for this speaker, we have two ways to ask those questions. So one is to just copy and paste your question into the Rocket chat in the website that we have, or you can also type your questions into the Q&A chat box on the Zoom. And yeah, why don't we get started? Okay, great. We have one question. They said, thank you for the nice talk. How do you define the patterns used in TCAV?
Okay, so first, thank you for having me. So the patterns in TCAV, it's a good question, and there's a whole paper you can look up afterwards, but very quickly here, imagine you want to grasp the notion, as I think I said in the talk, of stripes, right? To understand if stripes is important for the image classification of zebras. What you do is you seed a bunch of images of stripes to TCAV, and basically these can be stripes of anything. I'm not talking about stripes in zebra. It can be like fabric stripes, crosswalks, anything that has stripes. And you feed those examples to the model, and what you do is the model then captures that vector, that direction. So you have on one side all the images that have stripes that you fed it as examples. And then on the other side, you have random images of anything else. And so TCAV will find for you that direction, and that becomes the concept. This is the way that you capture that concept, if you will, in TCAV.
Great, thank you for the response. We have another question from the audience. Do you think that some of the tools could be used to reveal biases in the data itself? Some of the tools that you discussed?
Absolutely. So just because, for instance, we were talking about TCAV, for instance, one of the uses of TCAV is exactly in trying to uncover biases. So what do I mean by that? Imagine you have, again, an image classification of a doctor. And you can ask what concepts were important for this classification as a doctor, professional. And maybe some of the concepts that the model has found very important are things like a lab coat or a stethoscope. And those are all very good concepts for the decision that this is a doctor. However, if you also find that concepts around gender were important for this classification as a doctor, that may be problematic. So you may want to check on that. So that's one way in which you can use something like TCAV to uncover bias. Other techniques, the more visual techniques, in fact, that uncovering bias is one of the other reasons why you want to have these tools. So not only as explainability tools, but also as tools that will start to let you see some of the imbalances you may have in either your training data set or how your model is behaving.
I see. Along those lines, for both the demos that you showed, like in the facets example and also the what if tool that you showed in your talk, how do you typically go about deciding which features or visual characteristics you should prioritize for the end users?
For end users, the what if tool. So let me take a step back. It depends on who your end user is. If your end user in this case, for instance, using the what if tool, is a data scientist, some of the things we do, for instance, on the what if tool, one of the things we try to do automatically is we try to surface for you the list of features that we think are, for instance, the most unbalanced features. So either there is a weird distribution Or maybe these are features where half of the values are missing or something strange. And so we automatically try to surface that for you. But the truth is also, a lot of times we're not going to be able to automatically find the problem. So this is part of the reason why you want tools like the what if tool. So you, the human, can go in and inspect and try to understand, okay, what may be the features that are problematic here. One example of how you might want to do that on something like the what if tool, it has what we call counterfactuals. Now, I say that in quotation marks because this is not a causal notion of counterfactual. This is more like, imagine you are a bank, you're trying to decide on a loan, and you've given, you find someone in your data set who did not get approved for a loan. What you can do then is say, okay, anchor, what if tool, anchor on this person, and now show me the closest person to this person I denied and loan to. Show me the closest person who did get a loan, and highlight for me the deltas between these two people, the person who didn't get a loan and the person who got a loan. And that's how you can start to understand. And then it's up to you as the human to decide, okay, maybe some of these features are okay, and yes, I can see how this person got a loan and this person didn't, but maybe some of the features are not okay. And so that's, again, how you start to dig in and understand, is my model doing the right thing, or do I need to tweak it? Do I need to improve it to make sure it's behaving responsibly?
I see. It seems like it requires a lot of thought in sort of really deciding like what features the model should focus on. And yeah, on that note, what do you think are some of the major challenges for these tools going forward, especially as we start incorporating these methods into models that go into production and are used by like millions of people downstream?
Yeah, I think some of the challenges are things like, what are all the signals we can try to get automatically from these models versus what are the things where human